let's start with the first part with the CGE models. So I'll try to cover the following points. What are CGE? Why, in general, we can prefer CGE models to partial equilibrium models, and what are the benefits and the drawbacks as an empirical tool? And finally, what are the mechanisms and the steps in order to run a simulation in CGE models? So as you might know, CGE models, they stand for Computable General Equilibrium models. Computable because they can be calculated and we can use data in order to assign numbers to the variables or the equations that we have. So this is why we call them computable. General because we focus on all the economy, all the sectors, all institutions, different factors of productions. And equilibrium because we assume that all the markets that we have are in equilibrium, and the models because it's based on a system of equations. So this is why what we'll have to see what kind of data we can use in order to describe this computable thing, then what are the markets that we have, and how we can model them. This is why we're going to see the list of equations and the list of blocks. And finally, I hope that we'll have time in order to run a simulation and see what kind of analysis we can do with these simulations. Just quickly, the difference between CGE models and econometrics. So for econometrics, as you can see, we have in general either time series data or cross-section data. So it's historical data in general. Sorry? Hello? So is everything okay? Hello? Do you hear me now? Okay, so you didn't hear anything from the beginning. Shall I restart or? So everybody is hearing now? Okay. So I'll just start with this. So I was just explaining the difference between CGE models and econometric modeling. And as I said, in econometric modeling, it's an ex post analysis because we have historical data and we try to see what is the effect of what happened on a certain variable. But for CGE model, it's an ex ante analysis, meaning that before implementing a certain policy, we try to see what is the potential effect of what could happen later. And this is why for econometrics in general, we use regression estimation ranging from panel data to time series techniques to cross-section techniques and so on. But for CGE models, we do more simulations or deviation from the benchmark equilibrium. And by this, I mean that we have to see what is the status of the economy without a shock and what happens once this economy is subject to a certain shock. And that's what we call a simulation. For the third difference between both is that we have in econometrics, we have simultaneous equations and time series methods. And for instance, we have the impulse response function or any kind of similar data, any kind of similar technique that help us estimate the relationships between different variables. But for CGE models, we have two types of equations. We have either behavioral equations or accounting relationships. So for behavioral equations, they are related to utility maximization, cost minimization, profit maximization, and so on. And the second type of equations that we have in CGE models is accounting relationships like GDP is equal to C plus I plus G plus X minus M, for instance. The fourth difference between the two methods is related to the data size. So we know that in econometrics, the more we have data, the more robust are estimation results. But for CGE models, we do not really rely on data size because we just need data in the reference year or the benchmark data, like data that we have from a specific year for a social accounting matrix, for instance. And this is why, in terms of data, it's less demanding compared to CGE models. And we'll see later that, I mean, indeed, constructing a social accounting matrix might be costly, might be time consuming, but it is, I would say, in terms of data size, less demanding. For econometrics, the main problem that we face is the identification problem, meaning that how we're going to identify which variable, whether our variable suffers from any kind of endogeneity, for instance, or whether our estimation suffers from any technical problem like heteroscedasticity, multicollinearity, such problems. But for CGE models, the main issue is what kind of equation are we going to choose? Are we going to choose a Cobb-Douglas production function or a constant elasticity of substitution production function? Are we going to choose a static or dynamic model, and so on? The next difference between econometrics and CGE models is related also to the fact that for econometrics, in order to test the robustness of our results, we can run some econometric tests like Durbin-Watson test, White test, Sargen, Hausman, and so on and so forth. But for CGE models, given that we do not estimate, we simulate, as I said in the beginning, so we have to run some sensitivity analysis on parameter, on what we call macro closures or the form of equations themselves. And I will come later to the macroeconomic closure because it's one of the most fundamental things that we have to discuss in CGE models. Finally, econometric tools can be used for, they cannot be used for welfare analysis. While CGE models, given the fact that we focus or that we take into consideration the whole economy, so we can run a welfare analysis and examine what is the effect of a certain shock on all the economy at the same time. So based on this, what is, I mean, in more particularly, what is the definition of a CGE analysis? So it's an analytical approach that looks at the economy as a complete system, and by complete system I mean different all sectors, all markets, all institutions, or all economic agents. So we take into consideration different industries, all households, whether they are located in urban or in rural areas, investors, savers, government, importers, exporters, everything. And we try to see what are the direct and the indirect effects of a certain shock on the economy. So for instance, if we take a simple example, right, like what happens if we remove subsidies. So if we remove subsidies, the direct effect is an increase in prices. So that's the direct effect. So this means that consumption can decrease, and if consumption decreases, so this can affect total demand and hence total supply. But at the same time, we have two other things that we have to take into consideration, that reducing subsidies reduces public spending. And if public spending reduces this or decreases, this means that government will reduce its fiscal deficit, and this can reduce inflationary pressures, for instance. But at the same time, if subsidies are removed and prices increase, so real income is going to decrease, and hence demand can decrease. So all these direct and indirect effects can be taken into consideration in the framework of a CGE model. And in general, we have a representative producer and consumer. So we do not really look into the heterogeneity among producers or consumers, despite the fact that we have part of the CGE literature that runs what we call micro simulation. And for micro simulation, its main idea is that we run a simulation at the macro level, and then we examine the effect of this simulation on at the individual level. So this helps us examine to what extent we can have a heterogeneity among different households or different firms, for instance. Okay. Why is it better to use CGE models, not partial equilibrium models? For several reasons. I mean, some of them we have already mentioned. So first, because we can examine an economy-wide, or we can do an economy-wide impact analysis. And this can be done either at the global or at the level of each country. At the global level means that we can use a model that takes into consideration the whole world. So in this case, we were going to divide the world into, let's say, 25 regions. So USA, European Union, Japan, China, Arab world, Sub-Saharan Africa, North Africa, South Asia, East Asia and Pacific, and so on. And we run a simulation in one of these regions and examine the effect of this simulation on other regions. And this is very useful in general if we talk, for instance, about multilateral trade negotiations. Do you have any question? Hello? Okay. Is it okay? So global models, like and in general we have three main global models, which are linkage, that was developed by the World Bank, Mirage, that was developed by CP in Paris, which is a think tank in Paris, and GTAP, that was developed in the United States in Purdue University. So those are the global or multinational models. And we can have single country models meaning that they are models that focus on just one country and examine what happens between different sectors or different agents. And hence, we can also examine the effect of any kind of shock and take into consideration backward and forward effects from one sector to the other. So this is why that's one of the most important reasons why it's better to use CGE models more than partial equilibrium models. The second point is related to tracing distributional effects of consumer income changes, because as I mentioned before, CGE models they help us take into consideration direct and indirect effects. So, for instance, if we have a certain shock that can have a more significant effect on wages than on capital remuneration, for instance. So this means that those who own capital will be less affected by wage earner, for instance. So we can examine the distributional effects of any shock. The third reason is related to general equilibrium models, they have a broad scope. So for all households, all production workers, all markets, and so on. Fourth, they are flexible to handle because we can cover several policy areas, like environmental simulations, to run a simulation examining the effect of greenhouse gas emission, pollutions, imposing carbon taxes, for instance, all this. They can also be used in fiscal simulations. So what happens if we impose a tax, we remove a subsidy, we impose a subsidy, and they can be also used to run trade policy simulations. So what happens if tariffs increase, non-tariff measures are imposed, non-tariff measures are removed, and so on. The only area where we cannot use general equilibrium models is monetary policy. Why? Because general equilibrium models are real models. They are not, I mean, we cannot really model nominal shocks, for instance, in a computable general equilibrium framework. Why not use partial equilibrium models? Because the main problem of partial equilibrium models is that it assumes that a shock will produce a direct price change but do not have an income effect through the indirect effect on other variables. So again, if we take the example of subsidies, if we remove subsidies, so prices will increase, but we do not really look at the other dimensions of the shock. So what will happen with public spending? I mean, because reducing subsidies will help the government have a larger fiscal space, and so the government, when it has a larger fiscal space, is it going to increase its spending on education and health, or it's going to reduce its fiscal deficit, and so on? And that's the advantage of general equilibrium models. And this explains why partial equilibrium models cannot be really used to measure welfare or to have a welfare analysis. And this is mainly the beauty of CGE models. In terms of, because I mean, like any other quantitative tool, CGE models, they have benefits and drawbacks. So the main benefits, first, and this is very important actually, because one of the most important critiques that are addressed to CGE models is that they are like a black box, or garbage in, garbage out. And this might be a little bit superficial critique, because once we really understand well the theory behind CGEs and how we can use data of CGEs, they will not be definitely a black box. And I'll explain this in details now. Why CGE models they benefit, or they are characterized by an accounting and a theoretical consistency? Because CGE models are mainly based on micro and macro theory. So micro theory, they are based on consumer theory, with utility maximization subject to the income constraint, profit maximization subject to the budget constraint of the firm. They are based on the aggregate demand and aggregate supply at the macro level. They are based on consumption theory and investment theory at the macro level, and so on. So this means that we have a very strong and robust theoretical framework that explain why we're going to have a consistent framework to analyze the different economic relationships through a coherent framework. Okay, so that's from a theoretical perspective. From an accounting perspective, in general, we rely on social accounting matrices. And social accounting matrices, I will explain them later, but briefly, it's like an Excel sheet that contains all the economic aggregates in a certain country in a consistent framework again, because we assume that expenditure at the macro level is equal to revenues at the macro level, and this is why we can model different economic transactions ranging from savings to investment to export, import, consumption, input-output table, taxes, subsidies, everything within the social accounting matrices. So this means that we have an accounting consistency because we're using a consistent accounting document, which is the social accounting matrix, and we have a theoretical consistency because we are relying on the general equilibrium theory and along with microeconomic theories like consumer and producer theory, as well as macroeconomic identities. And this helps us have a conceptual and computational consistency through the Walras law. I'm not sure if you're familiar with the Walras law or not, but Leon Walras, when he developed the theory of general equilibrium, one of his most important, findings or arguments is that if we have n markets and if we have n-1 markets that are in equilibrium, okay, this last market will also be in equilibrium, and that's one of the most important assumptions that we have in CGE models, and this what guarantees that we're going to have a general equilibrium framework. Okay, along with this, given the fact that it's a general equilibrium framework, so this means that supply is equal to demand at the level of the whole economy, and that zero profit conditions for firms will hold, because in general we'll see that each firm will try to maximize its profit under a perfect competition framework, but it can also be we can also model imperfect competition. I don't think that we have time to cover this during these 3 hours, but in general, we can do it also in CGE models. The second benefit of a CGE model is that we can examine different inter-industry or multi-sector backward and forward linkages. Why? Because we have the input-output table that shows us how each sector depends on other sectors, and what kind of inputs are required from each sector in order to produce a certain good. So this means that if we have a shock that affects, for instance, again, let's take the oil subsidies example. So if subsidies on oil are reduced, this means that oil prices are going to increase, and if they increase, demand of different sectors will decrease. So definitely, the demand for oil, but through the input-output table, we can see which sector will suffer more, because this depends on the degree of intensity of using oil in this sector. Okay, so this is why these backward and forward linkages can be taken into consideration in a CGE framework. Third, as I said, we can run a welfare analysis to see what happens at the macro level when we take into consideration the effect of a shock on all the economy. Fourth, in terms of data requirements, it needs just a social accounting matrix, not a long time series, and we know that in several developing countries, time series, I mean, having a long and consistent time series sometimes might not be easy, but SAM is just I mean, the social accounting matrix that is available in a specific year, and then it can be directly used in a CGE model. And then the last benefit of a CGE model is that it can be used also at the individual level, as I said before, because we can replicate the macroeconomic shock at the microeconomic level through the micro simulation analysis. And I can share with you later some references in this, because we'll not be able to cover this now. The drawbacks of CGE models are mainly three. So the first drawback is related to the difficulties related to model selection, the parameter specification, or the functional form, because we must justify our choice. Are we going to have a production function that is a la Leontief, where we have complementary factors of production, or Cobb-Douglas, where we have substitutable factors of production, or we're going to have a linear production function? Are we going to have a constant elasticity of substitution production function? So all this has to be justified when we do a CGE model. Second, also the values of some parameters, because for some parameters we can calibrate them from a CGE model, and I will come to the calibration story later. But some parameters have to be taken directly from the literature, and if they are taken directly from the literature, we have to justify why we are using these values, not other values. Also, guaranteeing the data consistency of the SAM, because sometimes we can have, if we want to change the structure of a social accounting matrix, if this can affect the consistency of the data, and if the data is not consistent, meaning that the sum of each row in the social accounting matrix is not equal to the sum of the column of the corresponding column in the social accounting matrix, then we cannot run a CGE model. So this means that before starting to run a CGE model, we must guarantee that, or we must be sure that the social accounting matrix is perfectly consistent. Then for CGE models also, as I said, we cannot use them for monetary policies, especially. I mean, for fiscal policies, they can use if it's a real shock like subsidies or taxes, but for monetary policy, we cannot, because they are real models. Another drawback is related to the fact that we don't have a real statistical test that we can use in order to test whether our specification is correct or not, and that's what we have in econometrics. Because in econometrics we can have several econometric tests that help us examine whether we have a specific quantitative problem or not. Finally, CGE models also are costly to maintain, meaning that in order to maintain the model up to date and to add new equations or model new variables, they are costly, because every time we have to do to add different equations and to guarantee that these variables or these equations that are included in the CGE model, they have data in the social accounting matrix itself. Okay. So after going through the definition of the CGE, why it's better to use CGE models more than partial equilibrium models, what are their benefits and their drawbacks, I'll start with the CGE mechanism. And for the CGE mechanism is based on the most famous graph that we've seen in 101, Economics 101, with this diagram. So this diagram shows the different individuals and different institutions and different markets that we have in the economy. And we have, for instance, in this graph, we have 4 main institutions who are households, foreigner or rest of the world, firms, and the government. We have 2 markets, goods market and factors market. So what we try to do in a CGE model is to model everything in this graph. So we have to model taxes going from the goods market to the government. We have to model income tax that goes from firms to the government. We have to model taxes imposed on the factor market. We have to model subsidies going from the government to households or any kind of transfers. We have to model, again, those gray arrows between goods market and foreigners in terms of exports and imports. Between foreigners and the factor market, we have migration, for instance, of labor or movement of capital. We have households who are going to offer their services to the factor market, and the factor market provides factor of productions to firms. Firms are going to use these factors of production to produce goods, and these goods will be bought by households. So all these flows will be taken into consideration in a CGE model. And this guarantees, again, the consistency of the analysis. Okay? So all the equations that I will present later, their main idea is basically to show how we can first model this in a general equilibrium context, and then what happens if we have a shock in a certain market and how it affects the other markets. For the structure of the CGE, I'm going to start with the production side. So in order to produce, as you can see here in the upper left side of the slide, we have the production, and the production is based on different factors of production and intermediate inputs, because we need factors of production, labor and capital, land sometimes, and intermediate inputs. So we combine them in order to produce, and once they are combined together, we can have the production. So for the production, as you can see here in this arrow, we have 3 kinds of equations through which we can combine both factors of production and intermediate inputs. So either through a Cobb-Douglas, or constant elasticity of substitution, or fixed function. And what will be the main determinant to choose a certain equation compared to other equations? It's basically 3 things that help us, do or make our choice. So first, what is the say of the literature in this regard? So does the literature say that it's better to use constant elasticity of substitution more than Cobb-Douglas or not? Second, the economic rationale behind our function. So are capital and labor more complementary or more substitute? Because if they are complementary, we have to use a Leontief production function. But if they are substituable, then we can use either Cobb-Douglas or a constant elasticity of substitution function. And third, what is the case that we really study? For instance, it can be that for instance in Tunisia we can have more complementarity between capital and labor, but in Egypt it can be less the case, for instance. So this is why we have to to make our choice and to justify this choice. Why are we choosing a certain production function? So once we produce, our goods that are produced, they will go either to the domestic market or they will be exported. So if they are offered on the domestic market, it will be, domestic sales. If they are exported, this will figure under the exports side. And as you can see here, exports and domestic demand are combined through what we call a constant elasticity of substitution function. And what do I mean by constant elasticity of substitution? Constant elasticity of transformation, the CET function. So the idea behind is similar to the constant elasticity of substitution, but the difference, the economic rationale behind is that goods that are domestically produced, in order to transform them into exportable products, we have to transform them. For instance, by changing the labels or the packaging, or translating the labels that we have on ready-made garments, for instance, and so on. So this is why once we produced goods will be either sold at the domestic level or sold in the rest of the world through exports. And then with our domestic goods, we have also imports that come from the rest of the world. So domestic goods and imported products, they will represent the total supply available on the domestic market, and that can be and both can be imperfect substitutes. So once we have this domestic, this total supply on the domestic market that originates partially from domestic producers or from the rest of the world, these goods will be used by four main categories. So first, household will have their final consumption. Government will also buy some goods and services. And that's the G in our Y is equal to C plus I plus G plus X minus M. Firms also can buy part of these goods. And finally, other sectors, they will rely on goods that are produced in order to use them as intermediate inputs and produce their own goods. So this completes the whole story between total supply and total demand. So total supply comes either from total supply that is available on the market comes either from domestic sources or from foreign sources, domestic and imports, that are combined in order to satisfy the demand of households, of government, of investment, of intermediate use. And as you can see here in the lower part of the slide, for the trade balance, which is the difference between exports and imports. So that's mainly the structure of a CGE model. A final note on this is related to the Armington function. So for the Armington function, Armington was an economist at the IMF, and in the late 60s or early 70s, he published a paper where he showed that goods coming from different origins, they are imperfect substitutes. So meaning that geographical origin will affect the good itself. Meaning if I import ready-made